Okay, so we just did a video with an exponential growth model, a continuous exponential growth model. So now this is going to be a word problem with an continuous exponential decay model. So if any parts of these aren't terribly clear, you can go back to that first video, kind of watch through how we did a few of those parts. It's very similar. The only difference is that our rate is going to be a decay instead of growth. All right, so the mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 4.7% per day. Find the half-life of the substance, that is the time it takes for 1/2 of the original amount in a given sample of the substance to decay. Note, this is a continuous exponential decay model. Do not round any intermediate computations and round your answer to the nearest hundredth. So make sure you're paying attention to those extra instructions there, because that tells us, intermediate computations means within the problem, don't do any rounding, wait till the very, very end, and then at the end, make sure you round to 100th. So in the current problem, the number of bacteria follows a continuous exponential decay model. The growth rate parameter is R equals negative 4.7%, so here it is as a decimal, negative 0.047. The initial mass is P. When the half-life is reached, 1/2 of this mass will be decayed. So the remaining mass will be A equals P divided by 2. So whatever we started with, and then half of that. Okay, so they haven't told us what the initial amount is. They just said a mass. The only number we were given was a percentage here for decay. So we're going to have P divided by 2. That's going to be our A. We're substituting that for A. I just realized I will have to fix this. I didn't actually give the equation for the growth and decay model on this page. So it is on your notes page, and it was on the previous video. So darn, I'll have to fix that. We still have P. We have our natural log. Our decay rate is that negative 0.047, and T is time. Okay, so now we're going to divide by P on both sides so that we can get P away from here. And what it does is it actually cancels. P divided by P goes away, P divided by P cancels out. So I have 1/2 equals the natural log of negative, or 0.047 T. So basically this question now is, what is the half-life? So now I'm going to take the natural log of both sides. So the natural log of 1/2 equals negative 0.047 times T. So now I can divide by 0.047 on both sides. And I have the natural log of 1/2 divided by my decay rate equals T. All right, so this is where our calculator is going to come in handy. So I'm going to type in exactly that fraction. Make sure that you're dividing the entire top part by your decay rate. And when you hit equals, you will see that it's 14.7478, and they want us to the nearest hundredth, so I'm going to go to this 4, which is going to round up to 5. So 14.75 hours would be the half-life of this radioactive substance. All right, so that is an exponential decay model. I hope that helped, and definitely for the equation, go back and take a look at your notes pages or the previous video to see the equation that I was filling in there. So I hope that helped, and I will see you in the next video.